Hello, Tig Tigers. This is the second part of our science investigation, and it is the part about collecting data. By now, you are going to have all of your materials collected, ready to use, and you're going to actually perform and conduct your science fair project investigation. Whatever it may be, whatever you chose, this is the time when you're going to start actually carrying it out. So we're going to be working out of our Science Investigations Journal and recording all of our collection of the data inside of here. And it'll be on a page that looks like this one. We're just going to do 3 trials, but this is where our data is going to go. Our data is going to be the measurable and observable information that we collected. Now, this is also where you're going to put your information that you collect on this and you're going on this page, and you're going to make a graph. It'll have a title, it'll have the axis as well. Let's say that you're doing a science investigation where you're using time as a measurement. Well, let's just say, for example, that you're looking at different types of battery lives and you do your investigation the first time. You take out a flashlight or a toy that needs batteries, you put the different types of batteries in there, and that's called your trial number 1. But guess what? You have to do it again. That's going to be, once the battery runs out, you're going to put new batteries in your flashlight or in your toy, and you're going to do it again to see how long the battery life lasts. That's called trial 2. No, you're not done yet, because you still have to do it one more time. You have to do the 3rd trial, where you take the battery or the toy and you add another set of batteries and put them inside, turn it on to see how long it lasts. I made up these numbers, but let's say that my Duracell, the first pair of batteries lasted 61 minutes. That minutes is my unit of measurement. The second time I used Duracell, it lasted 70 minutes. Then it died. And then the 3rd time, my Duracell batteries lasted 80 minutes. That's called my 3rd trial. And then those batteries died. I would do the same thing with the Energizer batteries and put the batteries in the flashlight the first time, let it die out, put a new set of batteries in the second time, let it die out, and then do it again a 3rd time. We have to do 3 different trials, and you do it with your other battery as well. If I was to take this collection of data and put it into a graph, a bar graph, it would look something like this, with a title, color-coded. My Duracells are blue, the Energizers are orange, and my generic batteries are gray. I put the minutes on top as well, and then I put my consecutive multiples on the sides. That's one way I could organize my data if I was tech savvy. But let's say that I am going to go a different route, but I am collecting data on temperature, and I was going to see which liquid, like a drink, would stay the coldest after so many hours. So after a few hours, and it has to be the same amount of hours for each one, after 5 hours, I took the temperature of my drink in a styrofoam container, and it measured 15 degrees Celsius. And then I emptied it out. The second time I measured it, because I have to do a trial 2, the ice cold drink in the styrofoam container, and I measured the temperature. It was 17 degrees Celsius. And then I emptied that out. Then I did the same test in the same styrofoam container for the same amount of time. And then I took the temperature, and let's say that it measured 17 degrees Celsius. Well, now I'm going to do the same test, but in a glass container. And perhaps in my glass container, after so many hours, the same amount of ice, the same amount of drink, in this glass container, I measured the temperature, and it was 23 degrees Celsius. I emptied it out. I waited a few hours. I measured the temperature again, and let's say that it was 20 degrees Celsius. emptied it out, and did my third trial. So this is going to take me a while. And the third time I measured it after the same amount of hours with the same amount of drink in the same glass container. Let's say that I measured the temperature and it was 23 degrees Celsius. I'm using Celsius because metric is a measurement system of science. Instead of Fahrenheit, I would use Celsius. And then I would do the exact same test, but in my insulated container with the same amount of liquid, the same amount of ice, the same amount of time. And let's say that it measured 1 degree Celsius. The first time I empty it out. The second time it measured 2 degrees Celsius. I emptied it out. This is a lot of hours that I'm putting in here. Perhaps I can do one every day. And the third time, my third trial, the temperature measured 1 degree Celsius. So this is how I would record temperature. If I'm doing distance, let's say that my testable question was about different types of materials, and I'm going to measure the distance in trial 1 with the Nerf ball. Let's say that the distance was 20 meters. I would write it like this. And then the same Nerf ball, the second time I would go back to the start line. The distance was 15 meters. I'm not going to use feet. I'm not going to use the customary system. I'm going to use metric. And then the third time when I measured the distance, it was 25 meters. Those are 3 trials. I did my experiment 3 times with my Nerf ball. And then I would move on, say, to my plastic football. And perhaps the first time it measured 35 meters. I want to keep my units the same. The second time it may have measured 25 meters. And then the third time when I go back to the starting line, it may have measured 30 meters. So anyways, this is how I would record my information, my collected data on my table or my chart. And again, remember, I'm just showing you these numbers as an example. So you're not going to copy these because it depends on what your testable question was. If you are measuring capacity, perhaps you're going to be measuring in milliliters or in liters. So for capacity, I might be looking at different types of paper towels. And the first one may have just let go of 3 milliliters. And the next time that I put a paper towel in water and I squeezed as much as I could out of it, but only 5 milliliters came out of it. And then the third time when I dipped the same paper towel in the same amount of water, and then I squeezed it to see how much would come out, maybe it was 8 milliliters. But what I want to show you is that I'm not going to be measuring in ounces or cups. I'm going to be using milliliters and liters because that is metric. That's the metric system. And I would do the same test 3 times with one of my paper towels. And then I would do the same investigation 3 times with the other type of paper towel. I want to keep my units the same. And then I would do it 3 times again with my other paper towel, but with the same units. And that's how I would do it. Now, if I'm doing a count, I could do a tally count. Let's say that I'm looking at popcorn and I want to see which of these types of brands of popcorn leaves the least amount of unpopped kernels, which is not a good thing. You don't want unpopped kernels. If you happen to bite one, it's really hard on your teeth. You want all the kernels to pop open. So what you would do is, you would microwave it, each one for the same amount of time, open it, let it cool, and count the amount of kernels that were not popped. Maybe this left 25 the first time. So then you pop another bag for the same amount of time. And this time you counted 15 unpopped kernels. And then you put another bag in the microwave and you counted them and you found that it had 22 unpopped kernels. You would have to do the same thing with the next brand of microwavable popcorn. One time, count the kernels, put a new bag in the microwave, pop it for the same amount of time and count the kernels. So that is how I would do something that I was going to count if I'm not measuring temperature or if I'm not measuring length. Another thing that I could do is that I can draw a picture. If I'm just observing what happens to my science investigation, I can draw a picture of it, and that would be perfectly okay. There are pages where I can do my drawing. Something else that I can do is if I don't want to do my bar graph on the computer on Microsoft Word, I can draw it. I can get the graph paper from page 6 and I can draw my graph, my bar graph. A bar graph is very good for comparisons. It's very good for patterns. You want to color code it with your markers and label them. Always have a title as well. That's very important. Something else you can do is you can do, and let me make this a little bit bigger for you, you can do a line graph. Now, line graphs look very fancy, and they're good for showing growth and for showing pattern, but you've got to make sure that you label it, label the height, how many days you observed it, give it the title, color code it. That's going to be very important as well. Now, we can't tell you what type of graph to use, but there are many different types that you could use. If you're doing a survey, a great type of graph that you could use is this circle graph or a pie chart. And this is showing you the data for the effects of age on memory. This color was for the ones who remembered it wrong. And then this darker color is for those who remembered it correctly. So it all depends on what you're doing. It all depends on your data and what you're measuring, but make sure that whatever you pick, whatever you're observing, whatever you're measuring, you are doing it using the metric system. So I hope that everyone is doing well. I hope that everyone gets to start their investigation and see what the results are. Have a great day, Tigers.